Welcome back to the mountain bike build series. In this video, we're going to finish fitting the down tube into the frame, and then we're going to fit this top tube similarly into the frame. Let's get into it. So if you haven't been following the series, let me get you up to speed. We machined the outside diameter of this head tube just to give it sort of a different look. We drilled the holes in here so that I can vent gases while I'm welding. Then we did the seat tube. We machined this seat collar for the inside diameter fits the seat post, and we welded that in. And then we used my tube bender to bend this tube for rear wheel clearance. And then we drilled these holes, we mitered it, and then we went to the down tube. The down tube has been mitered to fit tight against the head tube. We got this cut here so it can fit on the bottom bracket shell. But you see, this needs to sit in the frame, and like these tubes sort of overlap. And I need to notch this one out so that they can both occupy their space at the same time. And I want the gap, down here between the two tubes, I want it to be essentially no gap. I want it to fit tight all the way around. You can imagine if you remove too much material, you have a gap. If you don't remove enough material, then they interfere and this can't sit where it needs to. And so that's the trick is if you do it all to the numbers and you have a real accurate and repeatable method, you can just make a cut with a hole saw for that. The way that I'm doing it with not totally ideal tooling and only having like one tube, I'm just going to sneak up with it. I'm going to sneak up to it with hand files. And so that's, I'll demonstrate that for you guys here. That's the first step. So the seat tube is sitting where it should in the frame, and this is sort of a sharp little pokey bit, and I'm going to scrape along here. This will leave a real fine line quality. So there's already Sharpie and there's mill scale from the tube. When I scribe this line, it gives me a nice, sharp, crisp reference. I can remove this tube, set it aside, and now I can set this tube in. And I have these lines that I put on here for side to side, so I know that I can get it centered. Just about like that. And now, what that does is that shows me, it doesn't show me the profile of the slice that I need to make out of here, but it shows me the extent of it, like how wide it is, and that's really helpful. So I'm gonna mark that on here. Just using my Sharpie like Dykem, just like a die. So I feel like I've said this 1,000 times, but this isn't really the best way to do it, but this is a way to hack through it. And in the interest of getting through this project, learning what I can from it, moving on and doing it better next time, I'm accepting that some of these methods are sort of hack methods, right? If I was trying to make a living doing this, I'd do things differently. But this is an idea I'm having for how I can mark sort of the extent of the depth of that cut. As I line this up about where it is, and then I sight from this attitude, I'm looking down this way, and where do these two meet when I'm sort of at that level? And I can just kind of make a mark that looks sort of eyeball-centric to where roughly it is, and that gives me just sort of like the depth of the crotch of that cut. Just gives me a very rough idea, so I can kind of work in that direction and check it, and I wouldn't want to start cutting way too aggressive or not nearly aggressive enough. I want to be reasonably quick without scrapping it. So basically, if I was going to miter this with a machine, I would come in with a hole saw that was 1 3/8" diameter. That's the diameter of the seat tube. And I would come in at a known angle, and I'd, not only would I have an angle, I'd be not offset from the center line in this attitude, and, I'd have a certain height here, and it's like a measurable sort of like a cylinder of material is sort of being cut away from this. You could model it in CAD by drawing a cylinder and then cutting that, or whatever you want to think of it as. So as I'm making strokes with the file, I can actually try to sort of remove virtually like a cylinder of material at a particular angle, to a particular depth, and that's sort of how I'm thinking of it as I'm using the hand file. But of course, I'm not a machine and I'm not a protractor and whatever, so I'm just gonna kind of sneak up on it. But that's one thing you can do. That's usually how I like to think of hand mitering. And so this doesn't have the same radius to it as the tube, but I can kind of do sweeping motions to the sides, and I can kind of interpolate that radius. I can kind of fudge it, and yeah. So first, I'm starting on sort of like a hill here, like a little an upward radius. And if I just do file strokes, what I'm gonna do is I'm gonna flatten that down first. And now I'm gonna start cutting into it. So I know I'm nowhere near being done. You know, I'm not even close to my marks. But I just want to put it in there and see what it looks like. So always sneaking up is the name of the game with something like this. It's really a very shallow angle. If you look at the angle between these two tubes, it's a pretty shallow angle that they meet. It's not a 90 degrees. It's not 45. It's pretty shallow. In fact, I'm going to pull that number out of BikeCAD. BikeCAD is really valuable for this kind of stuff. If you did want to make this cut with a hole saw, there's all different ways you could do it, but one way is you can pull these numbers out of BikeCAD. So this is in the Mitering dialog box. These two selections will show you sort of from the tip of that first miter back to the crotch of this secondary miter. That's 25 millimeters here. And then this angle, 51 degrees, that's, you know, the angle that this tube comes in at. And so with those, you could set this up for a machine miter, and you would use a hole saw that was this diameter, which is 1 3/8 or 34.9 millimeters. And that would be one way to make this cut. And if everything was exactly to the drawing and your hole saws were cutting right on size and you got everything aligned just right, then you'd be able to take that tube off of your machine where you would cut it and set it in the frame, and it would fit perfect. So yeah, the reason that I'm not doing that is I only have one down tube, so I can't really afford to screw it up. And you know, I tried to get close when I was mitering so that things would more or less fit the print. But you know, the hole saw is cut a little bit out of round, and you know, I just wasn't incredibly fussy about where I set stuff, and you would need to be if you wanted this to come out just perfect. And so I could do a preliminary cut on the machine, and then I could you know, work it in by hand, and that would save me some time maybe over the file strokes. But in this case, the point isn't for me to develop a system of manufacturing bikes that's repeatable, that I can do over and over again. The point is to get through the build so I can test this design, and so I can make videos about it and share that with people. And a lot of people are probably going to be interested in mitering tubes by hand. So I have my bevel protractor, and I've set this to the angle that we pulled out of BikeCAD. And so this is the angle that I would want to be making my file strokes at, roughly. And if I did this, if I followed this angle with every stroke of my file, and if the radius of my file was 1 3/8, and if I was able to hold it on the center line the whole time, then it would just be a matter of going until I hit my depth. And it's more complicated than that because this is not that true radius. But you know, knowing this angle here is kind of helpful, especially since I don't have a very good template to work to. It helps me, you know, sort of be in the ballpark. And I think I have it so that I can... Now you could maybe kind of do it at a different angle and kind of fake it in, but it's helpful to do it at the right angle. And if you look here, the flat actually, you know, there is some angle to it, and you know, I want to, when I'm done, I want to weld prep that so I can get the right amount of penetration. But I think actually hitting it at the correct angle is kind of what you want to do. So it's almost a knuckle buster here. I might lift it up a little bit higher. The further out of the vise you get, the less rigid it is, the more springy it is, but I think I want to get it a little bit higher. Okay, I forgot I bought a new file. This is a lot closer to the true radius, and it's this is gonna get, it's brand new, so it's gonna hog better anyhow. So set up this again. it just kind of reduces the variables I need to keep in my mind. The closer I can cut to the true radius and cutting at the right angle, it's going to automatically sort of rough in closer to where I want it. So based on how it looks, I can tell that I'm getting my notch pretty well on center, which is good. It looks like it's a reasonably tight fit to the radius, but this tube just can't sit where it needs to. You can see that there's a big gap back here because it's sitting further this way than it wants to. And so, you know, it tells me that I'm on the right track. I just need to be slow and careful. And that's the whole trick with this sort of thing is by the time you finally create clearance for this tube to fit where it should, if you go over in any spot along where they fit together, you can't really put that material back. So you really need to sneak up on it. But I can see that I have a pretty consistent sort of gap all the way around. It's not really heavy on one side and really light on the other side. And so, you know, that's a good sign. If you did this all the time, I think you could really get fast with this and effective with this. And I've heard some old school guys claim that they can, you know, miter each miter with a hand file in like a minute or two or something. You know, they probably use a grinder to rough it out, or, you know, tin snips to snip it out or something. And I am not very good at this because I don't do it very often. But, you know, if this is the tools you have and you do it over and over again, you might do okay. For me, if I was trying to make any serious volume of bikes, I'd want everything to be done on a machine, repeatably, quickly. I like that sort of process, and I think it ends up being faster and more repeatable. But, you know, you can get good with this sort of process. Yeah. So I've been back and forth a few times. I'm getting close, but then, you know, when you get close, that's really when you got to slow down and be careful. So what I'm doing here is I hold this tube in its spot and I push this tube so that it fits in the seat of its miter, right? And then I have this cone just about where it needs to be. And so I can kind of like rotate this tube. And as I rotate it in toward the crotch of the miter that I'm fitting it up against, I get it so that it touches, and then I look up here, and damn, I'm getting like within about a degree. I'm getting pretty close. So like every, you know, thousandth of an inch of material you remove down here that's interfering, that's keeping it from seating fully, that probably allows the top to swing, you know, 10 times as far or something. So you're really moving in slow and carefully. And, you know, I can see where it's touching. I'm making a mental note of that. And then I'm going to go back and file some more. And it's slow. So you see the gap. And as I swing it in, it looks like it's a little bit more tight in the middle than it is at the sides. And, you know, maybe a little bit more on like the non-drive side than on the drive side. So I'm just taking mental notes. All right, so I got it. And, you know, what I did here at the end was sweeping the C-tube forward. And I got it to the point where I swept it forward. It seemed pretty much forward all the way. And then, you know, holding these sort of in place and centered up where they need to be. Then I start lowering down this cone from above. And you can see the gap on it from the front and the sides and the back. The little, you know, the gap around there. And that's it's pretty damn well centered up. And then if I actually tighten it, you know, the gap looks good. We got a really small gap everywhere. This is a tough weld to do because you're coming in at a shallow angle. It's really easy to burn through the tubes, but that's about as close as you're going to get, and I feel pretty good with that. Maybe I'll dress it up a tiny bit. It's pretty much there. You get the idea. Let's move on. So, modeled up in BikeCAD, we have the water bottle cages. These are pretty accurate representations for normal cages and normal bottles. They usually sit pretty close to the representation in BikeCAD. That's what I found. And so from the crotch of that miter up to the center of the first water bottle boss, 215 millimeters, I'll mark that with a Sharpie, and then I'll use the Bridgeport to travel over 65 millimeters for the other one, and I'll drill those now. So from the end, 215 right there. So in the earlier videos, I've talked about using an edge finder to find your center line and stuff. So I'm just going to do these. What I did is I already had this tube block on here that I'm using for phasing, and I'm going to hold it by that. Ideally, I would hold it closer to where I'm drilling. So as I pull on the quill, it's pushing the tube down. It's kind of flexing things, but it's a stiff enough tube and it's close enough. I think it's fine. So I'm just going to go with it and be a little slow and, Can kind of support it out here by hand, I guess. So if this is 0, I just move over 65 millimeters. I think I did this right, but it's as I started to drill it, I said, this was kind of stupid. I should have done an idiot check. I should have made sure that I moved in the right direction, or I should have, it's just really easy to double check your work before you go drilling a hole. And I had this sort of like flash of, this is kind of stupid. Pretty sure I did get it right, but we'll just double check right now. So this is supposed to be 215, and then the other one should be plus 65. 215, 280, and I compare that to the computer model. 215, 280, that looks good to me. I didn't screw it up, but it would be really easy to do that. You put it on and then you move 65 millimeters in the wrong direction, or maybe mentally I'm thinking, of course it's 65 millimeters. I know it's 65, and turns out it's something else and I'm wrong, or whatever. So I'm glad I didn't just screw that up, but it's easy. It's really easy, and after all the time that I put into that, only having one of these tubes around, really kind of stupid to just go ahead and drill the next hole. I'm glad I got that right. So the only thing left on this tube is final weld prep. So I'm just gonna clean and deburr and all that stuff as I go to weld it. Maybe I'll touch this up to just get it even tighter fit, but this is pretty much done. I got the holes drilled. I'll double check the design, but I think this is everything. Sometimes you do holes on the bottom of the down tube, like on a touring bike or something, where you need extra water bottle cages or whatever. Some people on sport type bikes, like a mountain bike or something, they don't even put water bottle cage mounts, but I'm used to doing it and I want to be able to bring them with me, so I drill them on here. Anyhow, I think this is pretty much done. Let's move on to the top tube. Before we talk about the top tube, let me just ask, have you listened to the podcast yet? The Shut Up and Build Bikes podcast that I host. New episodes every Monday. It's up. We got 44 Bikes was the first episode. Oddity Cycles is episode number 2. It's coming out rapid fire. I have big dreams for it. And if you like the YouTube videos, I think you're gonna love the podcast. So definitely get your ears on that. And let's get back into it. So relatively speaking, compared to the down tube and in this case the seat tube, this should be an easy tube to miter. So we have 2 cuts to make at a distance away from each other. They're both on the tube's center line. There's an angle, and then there's a diameter of cutter. We flip it over, and we do an angle and a diameter of cutter. And that's about it. We just need to get them the right distance away from each other. It's a pretty straightforward cut. On the down tube, we had the head tube angle, which is, or the head tube cut, which is pretty simple. But then we had to get 90 degrees to that first one. We had to phase the tube to make the bottom bracket cut. Then we had a secondary cut. Then we had water bottle holes. This tube has just got 2 miters, no water bottle holes. It's a lot more straightforward, and we've covered a lot of these principles, so we're going to speed a lot of this up. But basically, I'm going to roll the tube, find the arc to it, then I'm going to mark my cuts based on where the butts are, and then I'm going to put it in the Miter Daddy tool, and I'm going to make my cuts and test fit it. And if I need to dress those just a little bit with a hand file or make successive cuts, I'll do that. But it should be pretty easy to fit in there, and we'll just see highlights along the way. And with the down tube, I talked about finding the butts if one butt is longer than the other. And there's a number of ways to do that. I didn't mention that they have a tool called a butt checker. Different people have made these. It's got a really fun name. I think Todd Farr from Farr Frameworks is maybe the person who is most who's making them right now would be your most accessible option if you just want to buy one. They're pretty easy to make, and I'll show a picture of it, but you just, you slide the tube into it. There's a dial indicator. Helps you quickly find where the butts are. And I made one for myself. I wasn't totally happy with it, and then I robbed parts from it for something else. But they're not that hard to make, or you can just buy one. It's a lot easier, and then it helps you establish the butts. You don't need to look at a chart or anything. I'm just going to go back to my old ways. I got it loaded up here. I'm using the Miter Daddy, and the Miter Daddy is my main tube mitering tool. And so this will hold tube diameters from 3/4 of an inch to like 1.875, which I think is 19 millimeters to 47 or something. And so it holds a very wide, range of round tubes. You can also hold non-round tubes, and you can hold tapered tubes. It's the big brother version of the Miter Buddy. It's my smaller tool for rear end, like tapered stays and stuff. And so anyway, I have it loaded up in here, which makes it pretty convenient. I have a Paragon block on here for phasing, and so I use a square against the table, the machine, and while it's loose here, I can spin the tube and get it clocked, and then when I flip it over end for end, I have a reference that makes it real easy. I also have I established the center line using an edge finder and my digital readout, which I've talked about in other videos. I double checked that this is the correct diameter hole saw, and I set my angle using the digital angle gauge, and the vise is tight. The table is basically locked down. I want to set the cut length. I don't want to cut off any more than I really need to. Something like that will be a good first cut. The spindle RPM is 210 revolutions per minute, which I think is conservative for this, but I'm not in a hurry. The gearbox is set to 6/1000ths of an inch downfeed per revolution, and so we'll just let her cut. I can see it's not really cleaning up all the way, so I'm going to feed in a little bit more and then take another cut. So I got a full cleanup. All of this surface here has been cut by the hole saw, and now I have my head tube and I can check the fit, and that's pretty good. Like I said in a different video where I was sort of talking about assessing the fit, it doesn't wiggle too much this way, and it doesn't like teeter-totter over these points in like this way. It's just a little bit loose in this attitude. That's not bad. You really can't see much of a gap anywhere around there. And so I'll just dress that and prep it for welding, and I'm pretty happy with that fit. Well, I measured the length and I scribed my line, and I scribed it as fine as I reasonably could there. Heavy Sharpie mark, and then use a sharp little piece of metal to scratch. And so what we need to be careful of here is we know the length across the top of the top tube, and we've measured that. And so there's a shallow angle here, or whatever, it's close to 90. And then here again, yeah, it's not a shallow angle. Here it's close to 90, and it would be real easy to just mix those up in your mind. If it was, really steeper angles or something, it would be harder to accidentally miter in the wrong attitude or something. So here, this is very nearly 90 degrees. I think it's like 91 degrees or something. And so I just need to be very mindful of the orientation of the tube as I go to miter it. So I'm setting up to make my cut, and I just want to idiot check myself. I want to verify that this is the right size cutter, right? Really easy to do this. This is 34.9 inch and 3/8. And I know that this is that size, but let me just check. Yep, it is. It's that easy. Now I know that I'm not using the wrong size cutter. I learned this the hard way more than once. So I want to make just a little bit of a a light cut, you know, like take off less than I absolutely need to on the first try, just to make sure that I'm where I want to be. And so you can see if you bring down the cutter while it's spinning, it'll make that mark relative to your fine mark that you made. And so, you know, I got about 1 millimeter or so there. I'll try making a cut at this length, and then see how it fits on the fixture, put it back on here, make another cut accordingly. So I just took the whole thing out of the machine, and I'm just doing a test fit to make sure that I'm not already too short, and I'm not. It gets tight before it gets in place. Depending on which of these angles is acute and which of these is obtuse, depends which way you load it in from. So you can imagine like an old school diamond frame road bike with a level top tube. The cut between these is going to be obtuse on the top and acute on the bottom, and here it's actually the other way because it's a small compact frame hardtail, but it's very close to 90 here. So in this case it comes up from here. But if I put that about where it needs to be, I can't quite get these into position. So yeah, I know that I need to cut more, which is just, you know, lets me know that I haven't already cut too much. Here we go again. So I've been sneaking up on it, and I feel pretty good about where it's at. So all I'm gonna do is just take off these tube blocks, and I'm just gonna you know, deburr the ends and dress it up, and yeah, I think this is ready for action. On the next episode of the Cobra Frames mountain bike build series, we're going to prep this thing for welding, and we're going to tack weld. I got to drill some holes in the bottom bracket shell, get rid of the mill scale anywhere that it's on here, wipe it down with acetone, and then tack weld it together in my lovely frame fixture. On the next episode of Cobra Frames... Should I say it like that?